Thank you for attending my talk, everyone. I am Karan Ahuja, a fourth-year PhD student at the Human-Computer Interaction Institute of Carnegie Mellon University. Today, I'm going to talk to you about Pose on the Go. This work was done with my collaborators Sven, Mayank Goel, and Chris Harrison at CMU. Pose on the Go is a full-body, yet zero-cost, motion capture system that uses sensors already found in today's smartphones, thus requiring no extra or external hardware. To achieve this, it uses an extreme sensor fusion approach. Using the front-facing camera of the smartphone, we can capture the relative spatial position between the head and hand holding the phone. As we do not have any data for joints such as the wrist, elbow, and shoulder, we use inverse kinematics to estimate and animate probable body poses. Simultaneously, the IMU allows us to orient the hand holding the phone. The hand that is not holding the phone generally cannot be seen or tracked, except when the user touches the screen, which then allows us to estimate the finger and arm position. By using the phone's front-facing depth camera, we can compute a chest normal, which allows us to orient a user's torso independently from the head and allows us to get the torso rotation. We can also animate the legs, despite having no direct sensor data below the torso. First, we use the phone's locomotion mode prediction to load the appropriate kinematic scheme, such as standing, running, or walking. Then, by using the IMU to integrate absolute body movement, we coarsely animate the avatar's legs at the appropriate speed. Finally, using the phone's rear camera and visual odometry software, we can estimate the elevation of the phone with respect to the ground plane, which, in turn, gives us the elevation of the user's arm and head. We feed this high data to the inverse kinematic solver, which allows our pose model to stand, step onto objects, and sit down. We performed a series of studies across 8 participants, benchmarking our approach against a professional-grade Vicon optical tracking system. Pose on the Go's error for estimating the head, torso, and wrist rotation is about 7.5 degrees, 16 degrees, and 10 degrees respectively. In terms of Euclidean error, the mean error across all joints is roughly 21 centimeters. As the root node for all these poses is the chest, the error increases as we move away from it. The absolute world tracking error is around 24 centimeters with the head height tracking error of 10 centimeters. Although Pose on the Go is, unsurprisingly, less spatially accurate when benchmarked with Vicon, the estimated pose is more than sufficient to power a wide variety of new and interesting applications. For example, it could enable a new full-body mobile gaming experience, such as this fantasy game. In this third-person shooter, the phone is a laser used to aim and shoot, and users can freely walk around and duck behind cover. Pose on the Go could also be valuable for health and wellness applications. For instance, phones could automatically count exercise repetitions and track performance quality. In this demo app, reaching exercises could be part of a physical therapy rehabilitation regimen. Similarly, today's face-centric Animoji could be extended to full-body animations, allowing for more expressive communication. It is important to note that Pose on the Go is only an estimation of full-body pose and is not meant to compete with high-accuracy tracking systems such as Vicon. It also has incomplete data about the body of the user, most notably the hand not holding the phone, which is almost never digitized except when the user touches the screen. In future, Pose on the Go can give a more comprehensive picture of the whole body by using the complementary information from the smartwatch to capture the hand that is not holding the phone. Also, it can use the camera to not only track the body pose but also the facial expression and appearance of the users.